Hello guys, I hope all of you are doing great. Today I'm going to show you the step-by-step process of doing hydrological model. I will show the process of hydrological model by NAM model, which is a module of mic. So we are all familiar with mic software, and it's a very powerful and commercial tool for hydrological and hydrodynamic model. So popularly, the hydrological model of mic is known as NAM, which is a net bore F-storming model. If NAM actually stands for net bore F-storming, which is a Dutch word. So first of all, you have to arrange the folder and subfolders, and you have to create some folders for your model just to keep the data in a arranged way. So let's get started. So this is my first folder. You have to open like this. Let's say this folder name is hydrological model. All the data result file will be saved on this folder, or will keep the associated files in this folder. In this folder, you have to open subfolders like this. First of all, EBP or evaporation, whatever you can name it. Under this evaporation folder, you have to keep the evaporation time series. So in this area, for which area you are doing the hydrological model, and how many stations, how many evaporation stations actually govern there, you must have this evaporation data, and you have to have the time series of evaporation and place the time series file, that is a DFSO file, in this folder. I have only one evaporation station which dominate my hydrological area, so only one time series of evaporation I have kept here. So how will you make a DFSO file or time series? I have prepared a tutorial on this, and you can watch this tutorial in my channel. So this is evaporation data, and this is MAE. Actually, these files, all the files have been created when you simulate the model. Nothing to do it with these files. This is MAE, that is mean aerial evaporation, and another one is MAR. These files will also be created when you run the model, or when you calculate the basin area. It will be automatically generated, so nothing to do with this file. Actually, these two folders will be empty, initially empty. When you run or simulate the model, this result file will be created automatically. MAR stands for mean aerial rainfall, and the fourth folder is result. In this folder, your result file will be saved. You will show the directory in your simulation file in this result folder, and the result file will be saved here during the simulation. And this is rainfall, the rainfall stations which govern your hydrological area. These stations data you have to place here in this location. Suppose for instance, in my hydrological area, there are two rainfall stations named Lakshmipur and Ramgoti. There are two time series, individual time series. I have just put here. Another one, it is very important thing, RR parameter. You have to create a RR parameter file before simulating a hydrological model. RR parameter means rainfall runoff parameter files. This is the main thing, the main important file. The extension is RR11. At first you have to create this RR1 file, and then you have to place that RR1 file in this folder. And the last of all, the same file, sim folder. Under sim folder, you will keep the simulation file. So now let's see how to create RR parameter file. First of all, this is my mic 0 interface. Then click on new. Then click on mic 11 module. Under this, there are some options. Click on RR parameter dot RR11. Double click on. This is your RR parameter file. You have to prepare this file according to your catchment characteristics, your associated data which are required for your hydrological model. So under this RR parameter, there are different kind of tabs like name, UHM, etc., etc. So I'm not doing any work on this file. I have a ready file. I'm gonna show that file for quick video. Let's say I have already prepared a RR parameter. I am opening this RR parameter file. So first of all, catchments. So this is actually a hydrological model of area. Area means a polder area actually. There are several khals, you know. There are 33 khals under that polder. The polder name is 59/2. So I digitized the catchment for each khal and found out the area and prepare the catchment like this. Catchment delineation is also important. What are the considerations for catchment? That can be another video. If you know how to delineate catchment, then you have catchment area, you have corresponding in the canal or river in that area. So this is the corresponding canal, the corresponding area of that canal. I mean the catchment or watershed area of this canal is 8.72 kilometers square. And similarly for all other khals, the catchment area is like this. If you want to add another catchment, then just click here, insert catchment. Then you have to write the catchment name, then catchment area, then it will be added at the end of this table. So another way you can do it, just if you have the Excel file, you have to insert the row and then copy from the Excel file, just paste here the all informations of catchment. Then come to the second tab, that is name. So you are seeing here so many parameters are here. So automatically for each channel or each khal or canal, there will be some parameters. These are the maximum water content, surface storage, zone storage, coefficient, time constant for routing flow, overland flow. These are the main calibration parameters actually. By default, the values that will appear when you are gonna do it, you will keep this value. After simulating, if you have measured value, you will change these values and calibrate your model with your measured discharge. What is the output of a hydrological model? You will get discharge, right? So if you have a measured discharge of a outlet, you can compare your simulated result with the measured discharge. If it doesn't match with your measured discharge, then you can change these values. Or if you want to know that what is surface storage, road zone storage, you can Google it what it is actually. Or if you are a student of civil engineering or water resources engineering background student, you must be knowing this terminology. I'm not going deep into this. This is the process actually. By default, some values will come and then you have to calibrate by changing these values. And similarly, this is the routing base flow constant, time constant, and groundwater recharge, constant root zones threshold value. Some default values will be appear, and you will do it by default value. Then if you want to calibrate the model, then you have to change it. These are also the calibration parameter of your hydrological model. Snow melt. Actually, in Bangladesh there is no snowfall, so we actually don't check mark it. If your country experiences or faces snowfall, then you can check mark it, and the corresponding value you can add. So irrigation, if you want to include irrigation, then you can, or otherwise just uncheck it, no problem. Initial condition as it is, you just keep it. Auto calibration, you can check mark it, then it will be auto calibrated, or otherwise it will not auto calibrated. You will have to change the values manually. This umax, lmax is the calibration parameter I have already mentioned before. These are the these are umax, lmax. These are the thing. Now the last step is time series. So you have rainfall time series and evaporation time series. These are the main data that you need to simulate a hydrological model. So first of all, data type, suppose rainfall. You have to show the path here. First of all, what you will do, see, you have to give the rainfall data from drop down here. Provide rainfall, then you have the rainfall station. So you have to go to the, see here, no valid items, so it's not finding. So you have to give here this one. Okay, now it's set. Again, there you can prepare several kinds of combination. These are the rainfall. So how many rainfall station you do have, you will set from here by clicking here. Suppose you have already set the Lakshmipur, then you add the Ramgati. Okay, so you have Lakshmipur and Ramgati. This 5 Ramgati. Okay. Station 5 is already there. I said it Lakshmipur. Okay. So I'm just giving you as an example. I will use the previous one. I'm just showing you how to add the rainfall station and evaporation station. So in every catchment, you know the percentage of Ramgoti station influence and the Lakshmipur station influence. So here 5 is Ramgoti. So you will give your percentage. Let's say it has 40% and it has 60% contribution for catchment 1 or for this canal. You have to set like this. Similarly, you will do the same thing for evaporation. Evaporation, there is only one combination will be there. You will set the evaporation data from evaporation. You will add the evaporation time series from your evaporation folder, and here you will give the 100% contribution of your evaporation station. You will set 1 for each catchment here. See, in every value there is value 1. And for every catchment, suppose for 1, after providing this, you will set the folder here, the mar. This is rainfall mar, and this one evaporation you have to set MAE. After setting for each khal, you will click on basin work area, calculate mean precipitation. You will click here. In the previous version, you must click here before simulating the hydrological model, but in the latest version you don't have to click on the calculate mean precipitation. When you start simulating, then it will be automatically created the associated files, the rainfalls that I have shown in the MAR folder and MA folder. It will be created automatically. So I'm not going to do this, and I will not save it. Let me show you now the theme file, the setup of hydrological model. This is the theme file of NEM model. Actually, how will you do it? When you open mics, let's say mic 0, when you open the mic 0 interface, then click new, then click on mic 1, and here you will see the simulation sim 1. Then this is the main interface of the NEM. If you want to run the Rainfall-Runoff model, that is hydrological model or NEM model, you have to check mark it on. You have to check it on. That's how you will open the sim file. So I am just opening my previous sim file, then I'm going to show you the step-by-step method how to set up the sim file. First of all, check mark on the rainfall runoff model. Then simulation mode is unsteady. Then input. What will be the input? Input will be only the RR parameter file. So from here, you can add your RR parameter that you have just created and add here, and you can edit your RR parameter file by clicking here. Okay. Then come to the simulation. Time step type, give fixed time steps type. We usually provide fixed time step and let the time step 5 minutes. Every 5 minutes the calculation will be done and the simulation start and simulation end. For which period you want to simulate the model, you have to provide the data correctly here or apply default. If you provide apply default, the rainfall or evaporation time series that you provided in the folder, rainfall or evaporation folder, according to that time period according to your data set, it will be set automatically. Otherwise, if you have a desired time period, then you have to put the time period manually. So RR, here you have to provide parameter file, then result, and RR, this is rainfall runoff. You have to show your result folder. This result folder you have to show here, or you have to name. You have to write the your result file and save. You'll click the save, then start. If you see the two green dot here, run parameters and RR parameters, so it is okay for your simulation. Your setup is ready, and once your setup is ready, you can go for simulation. Then click on mic 11 classic, then it will simulate your model and give you the result. So click on this. I'm not clicking on this because my previous result file will be deleted if I click this. Now let me show you the result file directly. This is result. This is my result file. See, we have runoff and net rainfall. So our main output is runoff. Let's see the runoff how. We can see the runoff for each catchment. Click on sorry, it's not responding because of my laptop's technical issue. Sorry for that. Okay, my result file has been just opened. So this is my rainfall runoff result, data type here runoff. Now see the list. So see all the channel, all the khals, all the canals in your area, in your model area are here, are listed very beautifully here. So if you want to see the runoff of Battir Khal, you can show the values or you can draw the graph. See, in my time period, I can find the values. This is my result of Battir Khal catchment, and this is the result of the canal and the outlet discharge actually. Now if you have a measured discharge in the outlet of that canal, you can compare your simulated result with this measured data, and then you have to calibrate your model by comparing your model result with the measured data. If it is not at satisfactory level, then you have to change the calibration parameters as I mentioned earlier. Thank you guys, thank you for watching this tutorial. I hope it helped you a little for developing your skill in hydrological model. If you find it useful, please subscribe my channel and share with your friends. And your subscription or your watching my tutorials will motivate me to make more videos. Thank you.